Welcome to True Projects. In this video, we are going to explain about a project titled Object Detection in Aerial Images, a large-scale benchmark and challenges. So now coming to the introduction part. Detecting objects in aerial images is a crucial field in computer vision, providing a comprehensive yardstick for assessing the performance of machine learning algorithms. Aerial imagery is acquired from a variety of sources like satellites, drones, and aircrafts, and it holds immense value for tasks like urban planning, disaster management, agriculture, and environmental surveillance. This opening highlights the importance of creative, extensive evaluation criteria for identifying objects in aerial images and briefly mentions the difficulties connected with this undertaking. So now coming to the objective part for this project is the extensive benchmark for object detection in aerial images has several key objectives. First and foremost, it acts as a crucial instrument for evaluating and setting performance standards for object detection algorithms designed specifically for aerial imagery. Through the provision of a standardized and rigorous assessment framework, researchers can gauge the precision, effectiveness, and resilience of their models, promoting fair competition and propelling progress in the domain. Furthermore, this benchmark stimulates the advancement of specialized object detection methodologies capable of addressing the distinctive challenges presented by aerial images, which encompass varying scales, intricate landscapes, and fluctuating lighting conditions. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Sequan for visualization are important. Second, here we have exploring the dataset. This step is about understanding the data you are working with. It includes reading images from the dataset and plotting them to visually inspect the data. Next, here we have image processing. Here the images are pre-processed to make them suitable for input into a machine learning model. This can involve tasks such as converting images to a format that the model can understand, a blob object, defining the classes of objects you want to detect, declaring the bounding boxes for these objects, and converting the processed data into a NumPy array. Then here we have loading the pre-trained model. This step involves obtaining a pre-trained machine learning model typically for object detection. You read the network layers of the model and extract the output layers which will be used for making the predictions. Next, here we have image processing. Further image processing is carried out, which may include appending annotation files and images, converting color channels, example, from BGR to RGB, creating mask and resizing images to a consistent size. Next, here we have data augmentation. Data augmentation is a technique to increase the diversity of your training data by applying random transformations to the images. Common augmentations include randomizing the images, rotating them, and applying various transformations to enhance the model's ability to generalize. Next, here we have installing the packages required for the YOLO V5 in Colab. This step involves setting up the environment, typically in a platform like Google Colab, to install the necessary packages for implementing the YOLO V5 model, a popular object detection model. Then next here we have processing the data based on the YOLO V5 model. This likely includes additional data processing specific to the YOLO V5 model, such as formatting the data to match the model's input requirements. Then we have building the model in Colab. In Colab or another environment, you create the object detection model. The outline mentions YOLO V5 and FASTA RCNN, which are two different object detection models. Then we have training the model. This step involves training the object detection model on your dataset. Training involves adjusting the model's parameters to recognize and locate objects in image accurately. Next, we have building the model with YOLO V5. This might be a continuation of step 9, specifying the YOLO V5 model architecture and configuring it for the training. Next, we have Flask framework with SQLite for sign-up and sign-in. It seems like we are integrating a Flask web framework with a SQLite database to create a user registration and login system, likely for the purpose of managing access to your application. Then we have user gives input as image or video. In this step, users of your application provide input which can be an image or a video for further processing. Then the given input pre-processed and with trained model is used for detecting the license plate. The user provided input is pre-processed and the trained object detection model is applied to locate and identify license plates in the input. Next here we have the segmented each object and put bounding box. After detection, the detected objects, that is license plates, are segmented and bounding boxes are drawn around them for visualization and further processing. And the last one here we have final outcome is displayed. The results including the detected license plates and any additional information are presented to the user, typically in a user-friendly format. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then we have another folder named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. Next here we have .ipynb file, which is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. Next here we have signup.db file. This file appears to the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and space the path over here. Now hit the enter button. Now type python app.py. And now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. Here I am using Chrome. Just paste the link over here. Now hit the enter button. So here you can see that this is our home page for the object detection in aerial images, a large-scale benchmark and challenges. It is showing about the FASTA RCNN, YOLO V5 RCNN and Mask RCNN. Here you can see that there is a button for sign up. Just click on this button and this is the registration form. Just enter your username, your full name, your email ID, your mobile number and your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. So this is the login form. Just enter the username over here and the password over here which you have created while doing the registration and simply click on login button. So here you can see that it is asking for uploading the image. Let's click on the choose file button and let me choose a file from this. So here you can see that we can choose any of the image from this. So suppose here I am choosing the second image over here and now click on open button and click on upload. So here you can see that it is detected as a playground. Let's try with another image. Click again on the choose file. Now let me select this area over here and click on the open button and click on upload. So here you can see that it is detected as mountain. So depending upon the image we are uploading over there, it will detect what type of object it is showing. And now here you can see that there is a button for about. Just click on this button and here you can see that it is showing about the YOLO V3 accident detection and YOLO V5 model. There is a button for sign out. Just click on this button, you can successfully log out with this. So now coming back to the conclusion part. To sum it up, the establishment of an extensive benchmark for detecting objects in aerial images marks a substantial advancement in the realm of computer vision. This milestone plays a pivotal role in prompting creativity, enhancing the precision of detecting algorithms, and most importantly, narrowing the divide between theoretical research and real-world implementation. By means of uniform assessment, this benchmark grants researchers the capability to refine and enhance object detection models to meet the distinctive challenges presented by aerial imagery, which holds great significance for a variety of sectors from urban planning to environmental surveillance. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.